So now I'm going to talk about Newton's first law of motion. So the Newton's laws of motion, so there's three laws of mechanics that describe the relationship between the motion of an object and the forces acting on it. The first law states that a body continues in a state of rest or in uniform motion in a straight line unless acted upon by a force. So let's take a look at what it means. So suppose here we have a box standing on a ground, and this box is at rest. There is no force acting on it. Apparently there is no force acting on it, but actually there is a mass of the box that is acting straight downward, which is denoted by mg, where m is the mass of the box and g is the gravitational acceleration. So since the box is in rest, the summation of the forces acting on the box is 0, so there is no net force acting on the box at this moment in any direction. So since there is a force acting downwards, which we call the weight, which is mg, there has to be a force, equal and opposite force, that is acting upward on the box, that is the normal force or the reaction force from the ground on the box. So this box is in motion, it's not in motion, it is stationary. So the Newton's first law states that this box will remain motionless until and unless there is an external force acting on it. So either we can push it or pull it, and then the box might start to move, but otherwise the box will stay still in its position. So this is a part of the Newton's first law of motion. Newton's first law also states that if it is moving in a uniform motion in a straight line, the velocity will not change until and unless there is an external force acting on it. So suppose there is another box standing on a frictionless ground, so it has been given a push and it is moving in a uniform velocity. So Newton's law states that it will keep moving in the uniform velocity until and unless any external force acts on it. So let's take a look at an example. A body is placed still on a ramp elevated at 15 degrees to the horizontal ground. Mass of the box is 50 kg. Calculate all the forces acting on the box. So first we're going to draw a free body diagram of the situation. So we have the ramp at 15 degrees to the horizontal, and we have the box at rest here, and it has a mass that is acting straight downwards, and the mass is m and the weight should be mg, that is mass times the gravitational acceleration. So suppose this is the weight of the box, and then there is a reaction force acting on the box perpendicular to the inclined ramp, and this reaction force should be Fn. It's the normal force. So another force acting on the body is the friction force that is acting up the ramp, and it can be denoted by Fr. So basically these are the three forces acting on the body right now, so that the body is at rest and it is not moving or it is not falling down. So this is the friction force. This is the force responsible for the body that it is at rest right now, because due to the downward component of the weight of the box should fall down the ramp. So now let's calculate the force W, that is we know mg. So we know the mass of the box is 50 kg times the acceleration due to gravity, that is 9.8 meter per second square. So it's gonna be 50 times 9.8, that is 490 Newton. So that is going to be the weight of the box. This weight force we have just calculated. So one of the forces calculated. So since the body is at equilibrium, all the opposite forces must be equal. So you see there's a reaction force in the body, and that is Fn, that is acting perpendicular to the ground upward. There has to be an equal force that is acting perpendicular to the ground downward, because the body is in equilibrium. So we can see that that force is basically a component of the weight force. So this weight force has a component that is acting perpendicular to this ramp, perpendicular downwards to this ramp, and this force must be equal to Fn, since the body is in equilibrium. So we have to find this component of the weight to find Fn. So now in this triangle, this is a right angle triangle, this is 90 degree. So this angle plus this angle is also going to be 90 degree, because three angles of the triangle sum up to be 180 degrees. So if this angle is 90 degree, this angle plus this angle has to be 90 degree also. So suppose that angle is x, so we can write x plus 15 equals to 90 degrees. Therefore x is gonna be equal to, so if we draw this triangle in here, we're gonna draw a replica over here. So we can see this is 90 degree and this is also 90 degrees, and we know this is 15. So this angle is going to be 75. Since this angle and this angle is 90, so this angle is going to be 15 degrees. So we know this force mg is 490, and if we take this component and this is the angle, so this component adjacent to the angle should be 490 cos 15 degrees, that is equal to 473 newtons. So since the body is in equilibrium, this downward force has to be equal to this upward force. So Fn, we know Fn is gonna be 473 newtons. So now we're gonna calculate the forces that is acting along the ramp. So these are the Fr, friction force, and it is balanced by the force, by the component of the weight, the component that is acting down the slope. So the force, this one that is acting down the slope, this force is equal to this force, since the body is in equilibrium. So this is 15 and this is 490 cos 15. So down the slope we will have the sine component of the weight force, that is 490 sine 15 degrees, that will be 127 Newton. So since these forces are getting cancelled away, they're in equilibrium, so this force must be equal to this force. So we can say that Fr equals to 127 Newton, that is Fr equals to 127 newtons. So to sum it up, we can write W equals to 490 newtons, Fn, or the normal force, equals to, we calculated 473 newtons, and the friction force up the slope, that is equal to 127 newtons. So these are all the forces that is acting upon the body right now.